channel.
Hello ladies and gentlemen, boys and girls. My name is Mr. Du and you are welcome to Mr. Du Science World. Well, today we are going to look at chemistry, and what aspect of chemistry are we going to look at? We're going to look at pH and POH. So we want to look at when we are given a given solution, how we'll be able to deal with the calculations of the pH or the POH of that given solution. So let's first try to understand what we mean by pH and POH. The first thing, when we say pH, what do we mean? pH simply implies the potential of hydrogen, and the POH simply implies the potential of hydroxide. So when we are looking at pH, what are we looking at? pH, once we are talking about a pH, then it means that we are trying to look at the amount of the H3O plus that is present in a given solution, or the amount of the H plus that is given in a given solution. That is what we simply imply by the pH. And now on the other hand, when we talk about the POH, then we are simply looking at the presence or the amount of the hydroxide ion that is present in the solution. So let's assume that I'm giving a solution. Here I have a solution, and I am trying to find out the amount of the hydroxide ion that is present here, or the amount of the H3O plus, which is the ozonium or the hydronium ion, or I want to find the amount of H plus, that is the hydrogen ion, that is present in this given solution. What I am doing is simply trying to do the calculation to see what is going to be the amount of the H plus or H3O plus or the OH minus that is given in this given solution. So how do we do this calculation? Let's begin that and let's see. Right. There are several formulas that we are going to make use of when we are dealing with the calculation of the pH. And I know that as a mathematics student, you are very familiar with the logarithm. So we employ logarithm in solving this particular problem. So let's try and see the formulas that we are going to make use of in this particular section. Right. We will look at formulas like when we try to look at the pH, then we can talk about the formula like pH being equal to negative log of the concentration of H3O plus, or we are looking for the concentration of the H plus. Either of the two is for us to determine the pH. So that is the formula number one when we are dealing with the pH calculation. Right. Let's look at in a situation where we are told to find the POH. Well, if I told to find POH, it is just the negative log of the concentration of our OH minus. That is also the formula for finding the POH. And if we are now, this is when the concentrations are given. What about if the concentration is not given, but rather we are given a concentration of, say, the OH minus, but we are told to find the pH. We know pH is related with with the H3O plus minus or the H plus minus or H plus. So if you are given the OH minus concentration and we are to find a pH, then we should be able to do that. How do we do that? The formula that will connect them together is that we know from this point that if we have the concentration of H3O plus and we multiply that by the concentration of the OH minus, it should be equal to the concentration, which is 1.00 times 10 exponent negative 14. right? Which is the value of what? Water at room temperature. So that becomes what we have, which is our KW. The KW, the equilibrium constant of water at room temperature. That will become this. So once we have this formula, if we are given this, we should be able to find this and find the pH. If you are given this, we should be able to find this and find the what? The pH. So whichever one that is given, we can apply this formula and then we'll be able to solve for any of the two that we are looking for. Let's look at another one, another formula that we can use to find out. Okay, what about if it happens that, okay, now we are given the pH or we are given the pOH and we are to find out the concentration of either of these two. How do we go about that? Alright, so from our mathematics point of view, we know that if we are given the pH or the pOH, then we can just simplify the H3O plus by just simply saying 10 exponents the negative log of the pH. We can also find the what? The concentration of the OH minus if we are given the what? The pOH by just also saying that, okay, then our concentration of OH minus is also equals to 10 exponent negative what? pOH. These will help us to be able to find out the concentrations when we are given the pH or the pOH. Now, let us now look for another formula that connects the pH and the pOH together. Alright, we know that on the pH scale it ranges from 1 up to what? Up to 14. Okay, so if it is 1 to 14, then we can just simply come out to say that there is a formula that also connects them, and that formula is just simply going to be our pH plus our pOH must also be equal to what? Must be equal to 14. And once we know these formulas, these are 6 formulas that will help us to be able to do what? To solve problems when we are to solve or when we are dealing with the calculation of what? pH and the pOH. So let's begin by looking at examples. Let's apply these formulas that we have written down. Let's apply the formulas. Alright, so let's look at examples. Okay, so let's look at these problems that we have on the board. Number 1, what is the pH if you have 5.22 times 10 exponent negative 5 molar concentration of what? H3O plus. So in this case, the concentration of the H3O plus is given, which is the hydronium concentration. The hydronium ion concentration is given, and we are told to find the pH. Once we are given a problem like this, you should think of these 6 formulas that we have and see which one is going to be the best formula for you to apply here. Right. So when we look at this, because we are given the concentration of the H3O plus, and we want the pH, we can see that formula number 1 best fits that particular problem. So we can use formula number 1 to solve the problem. So let's see formula number 1. So that is just going to give us pH is now equals to negative log of what? Of the concentration. And what is the concentration? The concentration is 5.22 times 10 exponent negative 5. And once we have this, we can just take our calculator and then we will see what that is going to give us. So we take our calculator and then we take negative log of 5.22 multiplied by 10 exponent negative 5. And once we have this, let's now check what we will have. So we can see that our answer is 4.282329497. So the question will be, how do I get my answer? Well, in this situation here, the sig thing is not that important, but my advice is that whenever you're given such a problem, leave the answer according to the sig thing that you are given. Right. So we can see this is intrinsic thing, So I'm going to leave my answer also in 3 seconds. And that is just going to be 4.28. And that becomes my answer. 4.28. And that becomes the answer to that one, to that problem that we were given. Let's look at the number 2. Number 2 says, what is the POH if you have 2.46 times 10 exponent negative 9 molar concentration of what? OH minus. Now we want the POH, and we are given the what? We are given the OH minus. So we can see straightforward, this is very simple. We can apply formula number 2 and solve for that. So that is POH is now equals to negative log of the concentration, and the value of the concentration is 2.46 times 10 exponent negative 9. And now I need to get the answer by just going straight into my calculator. So when I go into the calculator, what I have is exponent 9, okay, and now I am multiplying that, okay. So if you want to multiply all that together, what do we have according to the question is 2.46 times 10 exponent 9. And when we do that, we are getting 8.609064893. So I'm going to leave it in the same thing as this. So that's going to be 8.61. So I leave my answer in 8.61. And that becomes the answer to that particular problem. Let's look at question number 3 and let's see for question 3. For question 3, what are we given? Okay, so we see that in question 3 we are given the concentration. What is the concentration of H3O plus if pH is equal to 3.612? So here we are given the pH and we are going to look for the concentration. So we know that the best formula to use here is the formula number 1. So we go straight to formula number 1, or we can make use straight away. The best formula is the formula number 4, which is straight away making use of this and getting the answer. So, but I'm not going to use this. I just want you to get familiar to how to make use of number 1 to number 4. So I'm going to use the number 1 in getting to what? Number 4. So straight away. But if you want to solve the problem, once you understand how to make use of this formula, you can straight away use this formula number 4 to get an answer straight. So I'm going to use formula number 1, and that's going to be my pH being equal to negative log of the concentration of H3O plus. Now I will do the substitution because I'm giving the pH. The pH is 3.612. And that must be equal to negative log of the concentration of H3O plus. Right. Now from mathematics, if you remember the knowledge of mathematics in logarithm, when we have a problem like this, the first thing to do is to divide through by a negative sign. So this is going to be the negative 3.612 being equal to log of the concentration of H3O plus. And once I have this, now what is the next thing to do? The next thing to do is, I know that anytime I have log without any base there, it simply means that the log is in what? It's in base 10. And if it is in base 10, then I can just change from log into what? An exponential form or exponential equation. And that is simply just going to give me 10 exponent negative 3.612 being equal to what? The concentration of H3O plus, which we were told to find this concentration. So we can just straight away take our calculator and say 10 exponent negative 3.612. And once I do that, now again I am going to leave my answer according to the sigfig that I'm given. I was given 4 sigfig, so my answer therefore is going to be concentration of H3O plus being equal to 2.443 times 10 exponent negative 4. And That becomes the solution to the problem that I was given. Alright guys, let's look at more examples. Alright guys, let's look at number 4, 5 and 6 as well. Okay, so when we look at question number 4, we are told what is the concentration of the OH minus if the POH is equals to 9.565. Right. This is similar to what we saw in example number 3, and if you can see from here, we are given the POH. So, and we have to find the concentration of the OH minus. When we look at that, we can see that formula number 5 is the easiest way to get to the answer. Okay, but we can move from formula number 2 and get the answer as well. So formula number 2 and formula number 4, we can easily, formula number 5, we can easily use them to solve this particular problem. Because I have showed you in the previous example how to move from 1 to 4, it is the same approach you're going to use to move from 2 to 5. So I am not going to use that approach again. I'm going to straight away solve from what? The formula number 5. So let's see. From formula number 5, I am given concentration of OH minus is what I'm looking for. And I am given the POH. So this is 10 exponent negative POH, and the value of the POH is 9.565. So straight away, once I do that, I take my calculator and then I substitute that into it. So we're going to have negative 9.565. Okay. And when we do that, we are leaving it in the correct circuit, which is 4. So in this case, we're going to have 2.722. Sorry, 2.723. And that becomes the one. This is concentration, guys. So the unit must be in what? In the unit of concentration, which is what? Which is molarity. Okay, guys. When we look at question number 5, the solution is found to a pH of 5.61. What is the POH? If we look at this particular problem, there are 2 ways that we can solve this problem. We can simply use formula number 6 and get the answer straightforward, which is one way that we can solve the problem, and we are going to do that. And then the second way, in order for us to know how to make use of the formula number 3, we are going to solve it using an alternative way. That is, we move from formula number 4, because we are given the pH, so we will find the concentration of the H3O+, and then we move ahead to use formula number 3 to find the concentration of the OH minus, and then we will use formula number 2 to find the POH. So let's try that and let's see. First, use formula number 6. So to use the formula number 6, what we are going to have is the pH plus the POH being equals to 14. So pH is given as 5.61 plus POH, and that must be equals to 14. So therefore, our POH would now be equals to 14 minus 5.61. And let us now take our calculator and do that, or we can do this without the calculator if we so wish. We can have 8.139, and straight away we get that as our answer without even using the calculator, because we know from here we take out that and then we use that. So we get 8.39, straightforward. Right, that is one way to do that particular problem. Let's try and solve from formula number 4 to formula number 3 and then to formula number 2, which is the long way to solve the problem. Let's try that and let's see. Right. So if we want to do that, we are going to first apply the formula number 4. And what is the formula number 4? We are given concentration of H3O+. Okay, and that question wants us to find the concentration whilst we are given the pH. And the pH was given as 5.61. So we say 10 exponent negative 5.61 0.61. And let's see what we are going to get for our concentration. So we're going to have 10 exponent negative 5.61. And once we do this, we are getting it to be 2.45. Okay, times 10 exponent negative 6. Now this is the concentration of the H3O plus. So we're going to now use formula number what? Formula number 3, which is concentration of H3O plus multiplied by concentration of OH minus must be equals to 1.00 times 10 exponent negative 14. And what we want is this, so concentration of the OH minus would therefore be 1.00 times 10 exponent negative 14. We divide it by the concentration of this, which we have calculated, and we got 2.45 times 10 exponent negative 6. And let's see what we are going to have. So if we have 1.00 times 10 exponent negative 14, okay, and then we are dividing that by so we have 10 exponents negative 14. Okay, let's split that out there. And we are dividing that by 2.45 times 10 exponent negative 6. Okay. And this is going to give us 4.08. Okay, 4.08 times 10 exponent negative 9. And now I can use the formula number 2 by just taking the POH, which is the negative log of 4.08 times 10 exponent negative 9. Alright. I am using the actual values that I was given, so that I will get the exact answers that I want, so that it will be a more approximation. But that's going to be just a negative log of this which is given, or that which you have calculated. And straight away, once we do this again, we can see that we are getting 8.39, okay, 8.39, which is exactly what we got for the first one when we used the straightforward formula, which is the formula number 6. So we are getting the same answer, but this time around you can see that we have to go through a lot of calculations to be able to do what, to get to where we want to get to. Right. Now we have been able to know how to apply formula number 3. So in question number 6, we are not going to go by that approach again. We will go through that same approach because we are given the POH. So once we are given the POH, okay, we can also straight away move on to find the OH minus and find the H3O plus, and then that will help us from here. We will find the formula number 1 to solve for that as well. Right. But this time around, we're going to go straight forward. So I'm going to use formula number 6 to solve the problem quickly. So using formula number 6, that is the pH plus the POH being equals to 14. And if that is that, let's do the substitution. So what I have is pH plus the POH is given as 12.95 equals to 14. And that means that my pH is now going to be what? It's going to be 14 minus 12.95. And when we do this, we should have what? 1.05 as our answer to that particular problem. Straightforward, we use formula number 6 and we get that. But don't forget, you can just move away by using this particular approach as well. We'll find first finding the concentration using the formula number 2 and then he used number 3, and he used number 1. And that will also help you to find out the same answer that we have just solved right now. Thank you very much.
Please subscribe. Click the notification bell. Like, share, comment. Don't forget to subscribe to my YouTube channel. Thank you very much.